Algebra 1, Lesson 29, Solving Systems of Linear Inequalities. Just like with linear equations, we can also have a system of linear inequalities. To find the solution set of a pair of linear inequalities, we must find the ordered pairs that satisfy both inequalities. To do this, we need to graph and shade the appropriate sides of each inequality. After we do that, we'll see that the region where both shaded areas overlap is the solution set. To help us graph a system of linear inequalities with accuracy, we need to follow these rules. 1. Like before, make sure that y is on the left of each inequality sign. That way you will know the y-intercept and the slope. 2. Sometimes you may have to find the x and y-intercepts and then graph each inequality. 3. Graph the first inequality and shade the appropriate area. 4. Graph the second inequality and shade the appropriate region. 5. When drawing the graphs, remember to draw a solid line if less than or equal to, and greater than or equal to signs are used. Draw a dashed line if less than and greater than signs are used. 6. The region where the two shaded areas overlap is the solution set. 7. Check your work by using a point from the overlapped area. Substitute it into each inequality and evaluate. They both need to read true statements. Let's work on an example. Example 1. Graph the following system of inequalities. Check to see if the point, -1, 5, is part of the solution set. Pause the video and work on this problem. We'll have the solution in the next part. Your graph should look something like this. Now look at the point, -1, 5. Think about this carefully. Is point -1, 5 a solution for both equations? I'll give you a second. If you said yes, then you were wrong. The point, -1, 5, may be a solution for the second equation in the system, but it is not a solution for the first equation. So the point, -1, 5, is not part of the solution for the system of inequalities. Example 2. Which one of the following points are a part of the solution for the previous system of inequalities? A, -5, -1, B, 1, 4, C, 0, -4, D, 1, -3. If you chose D, then you are correct. A couple of the other points may be solutions for the equations individually, but mutually, they are not valid for both equations. To do a quick check, let's substitute the x and y values and evaluate to see if we end up with true statements. So, as we just worked it out, we ended up with true statements when we evaluated the system of inequalities with a point from their solution set. If we wanted a more algebraic way to write the solution set to be all-inclusive, we would look at the intersection of both lines and see that the shaded area represents all x values greater than 1/3, and all the corresponding y values are less than or equal to -1. You could also solve the system like we do with equations, with the substitution and elimination methods. But I feel it's easier to graph so you won't get caught up with mistakes like forgetting to flip the signs and such. In conclusion, solving systems of linear inequalities need to be done carefully because of all the different technicalities with the true solution sets. The substitution and elimination methods could be used to solve them as well, but graphing them lets you see the whole picture more clearly, in my opinion. In any case, use what method that is practical and that you're comfortable with.